all three speakers were actually talking about information technology as a tool for modern development. Now we are going to divert from this topic to explore the role of engineering and technical sciences in acceleration of economic growth in Sri Lanka. May I call upon Dr. Ananda Jayawardena. He is the Dean, Faculty of Engineering in University of Moratuwa. He holds BSc Engineering in Civil Engineering with first class honours in University of Moratuwa, MSc in Construction, UK with first in rank. He also holds PhD in Construction Management, University of Technology. He is a professional engineer with active involvement with professional bodies and industry. It's you.
Session Chair, Honorable Partly Champakranavika, Minister of Power and Energy, the Secretary to His Excellency the President, Mr. Lalit Veeratunga, the Vice Chancellor of the KDU, Major General Milinda Piris, members of the panel, other panel members, members of the Tri-Forces, distinguished invitees, ladies and gentlemen. It is challenging to speak at the last session, but I have one advantage because there is nobody to speak after me, so I can take a little bit more time.
Time is running out. Huh?
Yeah. My topic is very broad because I need to talk the entirety of engineering sciences in acceleration of economic growth in Sri Lanka. I'll be talking under these 7 topics: our targets for economic development, opportunities in the engineering sciences, producing world-class graduates, the need for innovation, need for entrepreneurship, need for national innovation system, and the challenges and the way forward. His Excellency, the President Mahinda Chintana, Vision for the Future, he said, the people of our country are now awaiting the victory in the economic war in a manner similar to our victory in the war against terrorism. Over the next 6 years, I will dedicate myself to increase our per capita income to well above $4,000, thereby placing our country in the ranks of middle income nations. It's a very ambitious task, and therefore our target from current GDP per capita of $2,400 to $4,000 in 2015, which actually means that we need to actually have a rapid economic growth. And from engineering point of view, in order to have this rapid economic growth, you actually need to concentrate to high-tech exports or value-added exports. And at the moment, the value-added exports is only 1.5%. We need to at least target about 10% by 2015 to have this target. And in fact, the coming colors are very good, and we are in fact having a very good economic growth. Through real growth rate, GDP per capita is over 9%, according to the statistics. The target for economic development, the development means if you want to rapidly create wealth for our country to increase per capita income, we need to export more and earn from exports. And we need to reduce our import expenditure through import substitution. And in fact, we need to create that kind of a conducive environment to in fact widely use that opportunity. And this is where engineering sciences can play a dominant role. And if you use the engineering sciences principles in an effective way, the key outcomes are you have high value addition in our products and services, not just like agriculture, but high value added products, knowledge intensive products, national and international competitiveness, and we will become more innovative nations. And this can be effectively harnessed by promoting entrepreneurship and creating innovation and entrepreneurship or entrepreneurial culture. This can be made through effective harnessing of engineering sciences in many disciplines that we have. And in fact, unlike the IT, I have many disciplines, but I'll take a couple of engineering disciplines just to explain how we can make use of this opportunity. Chemical and process engineering, convert raw materials to products, waste with a treatment process, energy, useful raw material, useful products, but many opportunities. Petrochemical industry, food and beverage manufacturing, sugar industry, confectionaries processing, polymer industries, personal products, and many more like paint, pharmaceuticals, cigarettes, paper, solid waste treatment, cement manufacturing, wastewater treatment. And future, we have lots of application in the nanotechnology. The session chair indicated right at the beginning that we are in the era of biotechnology, nanotechnology, neurotechnology, information technology. Lots of developments and opportunities. If you consider the traditional civil engineering, which actually has many, many other disciplines like structural and solid mechanics, where we actually put up buildings of about kilometer high, various other structures, waste treatment and environment, transportation systems, geotechnical and soil mechanics, where we do things underneath, under the ground, hydraulics and water management, construction management. And in the 20th century, we also had visionary engineers like Dr. N.S. Kulasinghe doing these marvelous structures. And the opportunities in the 21st century, we are already enjoying and in fact getting involved. These are the infrastructure projects that are just completed and in the process. Kenya Bridge in the north, Noracholi Power Plant during construction after the first phase, after all the 3 phases where we have 900 megawatts generation. Upper Kotmale Hydropower Project. Southern Expressway, where the time of travel from Colombo to Matra will be less than 1 hour and 20 minutes. Magampura Seaport during construction and after completion the model. And this is actually to exploit the Silk Route that we have. The Sangupiti Bridge connecting people. Hambantota Airport, the model and the site. Colombo Port Expansion Project. Lots of challenges. And civil engineers, therefore, make the difference and they build the quality of life of people. And that's from the American Society of Civil Engineers. If you consider a discipline like materials engineering, you have, say, you treat about the metals, the ceramics, the polymers. The advances are you have smart materials and structures, biomaterials, nanostructures, high-performance composites. And these are, capacitors, piezoelectronics, thermistors, sensors. I will go into the details, but all are developments in this one. The bioengineering applications, where you can have lots of, human, organs, plants, and things like that. So you have key required materials for sensors, intelligence wound dressing, silicon chip implants, personal health monitors, miniature power sources, artificial tissues and organs, new materials, and drug release membrane. Lots of, light aircraft carrying lots of people, and the kind of speeds that are happening now, it's unimaginable. Electronics and telecommunication industry is a rapidly growing industry with a market more than $1 trillion worldwide and with lots of high value addition. In Sri Lanka, during the past 10 years, we had only 1% growth, and it is an opportunity that we can exploit. We have 5 major sectors like electronic component industry, consumer electronic, computer and office equipment industry, telecommunication, and industrial electronic industry. And the business prospects, moving towards Asia, and this is where the engineering sciences can be in fact used to create wealth for our country as well. And these developments, medical electronics, personal robotics, smarter mobile devices, consumer electronics, and things like advances, smart homes where lights will come on and the kettle will go on when you come into the house. A house which will call you if you are late to see where you are, kind of developments. Electrical engineer, we have the minister here. And lots of applications, power generation, high voltage,